Draw the projection of the following points on the same ground line, keeping the projectors 25 mm apart. So guys, basically here are 7 different points from A to G. Alright, what we're gonna do is we'll be identifying for each and every point. We'll be identifying what is the value of H. H is something that we call the distance from horizontal plane, and we'll also identify what is D. D is something that we call the distance from vertical plane. Okay, so the distance from horizontal plane is H. It's going to be either above horizontal plane, that means it could either be first or second quadrant. The distance or H could be below the horizontal plane, that means the case could either be of a third quadrant or a fourth quadrant. Similarly, when we speak of distance in front of VP, you would say that it may be the first quadrant or fourth quadrant, and if we speak of distance, any distance behind the vertical plane, then only 2 different quadrants come to my mind, that is second quadrant and third quadrant. I guess you would be in a much better position after you have seen the previous video when I delivered the concepts regarding points placed in different positions and the various cases that I've explained there. Okay, so right now we'll begin with point A. Alright, so point A is in the HP, that means its distance from horizontal plane is absolutely 0, that is H is equal to 0 for point A, and 20 mm behind the VP. Behind the VP, only 2 things could happen: either this point is in the second quadrant or this point is in the third quadrant. So both the cases are absolutely valid. You can either assume point A to be in the second quadrant, or you can either assume it to be in the third quadrant. What we're going to assume is we're going to assume that point A is in the second quadrant, and by the logic of second quadrant we know H and D, the distances H and D are above XY line. Okay, starting. Okay, right now we're gonna draw this XY line. Alright, and we're gonna draw the projection of point A. H is equal to 0 and D is equal to 20. So H is 0, so it's gonna be somewhere here, and D is absolutely 20. H and D both are up or above XY line. We need to write with H, always put a dash for any point that you are drawing the projection of, and with D, distance D, this is distance D, don't put a dash. That means A dash will be here and A is going to be here. That's it, folks. Here it is. Well, that's it. That's how the projection of point A will be done. Alright, moving to point B. As far as point B is concerned, point B is 40 mm above HP, 40 mm above HP and 25 in front of VP. That means H is equal to 40 and D is equal to 25, and this particular point is lying in the first quadrant because the point is above HP and in front of VP. Alright, so as far as the logic of first quadrant goes, we know that H is going to be above XY line and D is going to be below XY line. Fine. So from this point at a distance of 25 millimeters, I'm again going to put up a point, and you know that the projectors are to be kept 25 millimeters apart. So how many projectors would be there in totality? It would be somewhere around 7 projectors, and each of them have to be separated by a distance of 25 mm each. Now the next thing that we're going to do is H is going to be above and D is going to be below. H is 40, D is 25. Fine. So from this point over, you need to go 40 steps up, and from this point again you need to come 25 steps down. This is going to be the projection of point B. Alright, we're gonna write this is distance H, so you will write a B dash over here, and this is D, no dash, that means simply B. Right, good, something like this. Dimensions, you can do so. This is going to be 40 and this is going to be 25. Right, so we now have the projection of point B. Bingo. Now let's move for point C. This is going to be again at a distance of 25 millimeters, and as far as point C is concerned, let us see in which quadrant this point lies. C is in the VP, vertical plane. Okay, fine. So in 40 mm above HP. So there is a point C which lies in the vertical plane and it is 40 mm above HP. Now you can either say that this slice belongs to first quadrant, or you can also say this belongs to second quadrant, because it is above HP, and above HP there are two quadrants, first and second. Okay, now if we consider this to be in the first quadrant, we know the value, it's in the VP. That means its distance from the vertical plane is absolutely nothing, because it lies in the vertical plane. That means D is going to be 0, and it is 40 mm above HP. That is H is going to be 40. Alright, so H is going to be above XY, D is going to be 0. So let us do this. H is going to be 40 and D is going to be 0. So D is going to lie over here, somewhere here. Okay, so this point, this is H, this distance over here is H. Let me indicate this distance over here is H. Okay, and if this is H, a dash will be put here against this point C. C dash will be here, and C is going to be here. Let us do it quickly. Well, that's it, guys. Now coming over to point D, you can see this point D is 25 mm below HP. Now below HP there are two quadrants. Either it could be quadrant number 3, or it could be quadrant number 4. Let us see whether the point is in front or behind. If it's in front, then we would say that it's fourth quadrant, and if it's behind, then we would say it's third quadrant. Let us see. 25 mm behind VP. So the case is pretty clear. This particular point D lies in the third quadrant, for which the values of H and D, distances H and D. Okay, so there is a coincidence. The name of the point is D, and the distance is also denoted or represented by D. Alright, so don't get confused. H and D for these 2 points are 25 and 25. Okay, so let me put a point over here at a distance of 25 millimeters, and H is 25. Okay, since it is a third quadrant case, H is going to be below. So 25 below, H is below, and 25 up. Okay, and as far as point naming is concerned, so below we have distance. This distance was H, so with H you need to put a dash, so D dash. And the next thing that we'll be doing is, this is going to be simply D. Okay, all right, that's it. That's it. So 4 points are over, 3 more to go. Let's go for it. Point E, 15 mm above HP and 50 mm behind VP. Sounds similar, 15 and 50. Let's not get confused. 15 mm above HP. Now only two things come to my mind. Above HP, that means it could either be first quadrant or second quadrant. 50 mm behind VP. Okay, this is a clear-cut case. It's behind VP, that means it has got to be second quadrant. Alright, so what we're gonna do is, we know the value of H is going to be 15, 15. The value of D is going to be 50, 50. It's a second quadrant case. H and D, both of them will be above XY line. So let us do this quickly. Let me put up a point. Again, this point is at a distance of 25 millimeters from the previous projector. Alright, wait, made it or not? Yes, sir. Now H and D, both of them will be above. Alright, so this is going to be 15, and there is one more point. This is going to be 50 from XY line. Well, that's it. What we're going to do right now is, I'm going to do this. Please, this is 50. Alright, where is 15 gone? It must be somewhere here. Here it is. This is 15. Now guys, this is for point E, and let us differentiate between 50 and 15 in terms of H and D. Now 15 mm above HP, that means this dimension over here is H. If it is H, you need to put a dash against the name of the point. So since the name of the point is E, you need to put E dash over here, and this 50 is, let me do this quickly. This is going to be simply E. Alright, that's it. Now as far as point F is concerned, point F is 40 mm below HP. 40 mm below HP. Oh, let me think. got to be third quadrant or fourth quadrant. Let us see whether it's in front of VP or behind VP. It's clear cut case in front of VP, that means it has got to be fourth quadrant. The value of H again is 40, the value of D is 25. If it's a case of fourth quadrant, that means H and D, both of them will be below XY line. Okay. H and D, what is the value of H? H's value is 40, value of D is 25. 25. All right, where is the point? Well, that's it folks, and this over here is 25, this distance over here is 25. So let me give it the dimensions. This is 25 and this distance is 40. Now let us again check whether 25 is H or D. Okay, if one is H, then the other one has to be D. Now if 40 is below HP, that means this dimension over here is H, and if it is H, then this has got to be F dash. You need to put a dash always with any dimension that is for H, and then this has got to be F simply. Now the last point, G in both HP and VP, that means it's a case in which there is a particular point which lies both in horizontal plane and vertical plane. This can only happen on the reference line. Okay, this can only happen along the line where both the planes intersect each other, that is the reference line or the XY line. Fine. Alright, let us finish it off. So this is 25 and this is exactly the point over here. You're gonna write G dash, and here itself you're gonna write G. Alright, both HP and VP, that means the value of H and D for both the for G is actually 0. If H is 0 and D is 0, so both front views and top views are gonna be here itself, that is on the reference line. A point P is 15 mm above HP and 20 mm in front of VP. Another point Q is 25 mm behind the VP and 40 mm below the HP. Well, moving ahead, draw projections of P and Q keeping the distance between their projectors equal to 90 millimeters. And finally, draw straight lines joining 1. Their top views, 2nd their front views. Now guys, this was the question, and now let's see what we need to do. Okay, so there is this guy named point P. Okay, this is 15 mm above HP and 20 mm in front of VP, above HP and in front of VP. So one thing is for sure, that this particular point lies in the first quadrant. Value of H is 15, the value of D is 20. Let's write point P, the value of H is 50 and the value of D is 20. H is going to be 15, D is going to be 20, fine. And point P, it's a case of first quadrant. Alright, now let's read it further. Another point Q is 25 mm behind the VP. Behind the VP, well, we only have two options behind the VP. It could either be second quadrant or third quadrant. Let us read it further. 40 mm below HP. Then one thing is for sure, if it's behind the VP and below the HP, then it's a clear-cut case of third quadrant, in which the value of H is 40 and the value of D is 25. Alright, H is 40 and D is 25. So where is it? H is 40, D is 25, and point Q lies in the third quadrant. Well, that's it. One more thing which is left is keeping the distance between their projectors equal to 90 millimeters. Okay, this is something which we need to incorporate in our drawing, and they have to be separated. The projectors of P and the projector of Q are to be separated by a distance of 90 millimeters. The distance between them is going to be 90. Look guys, make sure that all these distances are in millimeters. Alright, so let's begin. Point P, first quadrant, H is going to be above XY, D is going to be below XY, 15 above and 20 below. First quadrant, that means front view will be above XY, top view will be below XY. Alright, so let us first start by drawing a line or a reference line, or what we call popularly known as XY line. Alright, so here is the very popular line, XY line, reference line. Now what we need to do next is about this particular point P, for which H and D are 15 and 20. H is going to be above XY, D is 20 below XY. Alright, so 15 above and 20 below. Here it is, 15 above and 20 below, and this dimension over here is this is 15. Alright, and this over here is 20, and this is point P. Now this over here, this is what you call H, distance H, and if it is H, then you need to put a dash corresponding to whatever name of this particular point is. If it's P, it's got to be P dash. Similarly, this over here is the dimension D, and with dimension D we don't need to put a dash. Okay, so you need to simply write P. Guys, one thing which you guys should know, this is vertical plane, and this is front view on it, and this is the horizontal plane, that is below XY line, and this is the top view on it. Okay, so there is another point, that is point Q, and the distance of point Q from the projector of point P is what is it? It's 90 millimeters, right? Alright, and then for point Q we have the value of H and D as 25 and 40. Now since point Q lies in the third quadrant, that means H is going to be below XY, whereas D is going to be above XY. So 25 will be above XY and 40 will be below XY. Let's do this quickly. 25 is going to be above XY and 40 is going to be below XY. Alright, now 25, this distance over here is D. Okay, so with a D you don't need to put a dash, so it's Q, simply Q. And this distance over here, this larger distance, relatively larger, 40 millimeter, this is H, so you need to put a dash over here. Since the name of the point is Q, it's got to be Q dash. Well, that's it folks, and some dimensioning is left, I guess. It's going to be something like this. This is 90 millimeters, and some more. This over here is 25, and this guy over here is 40, and that's it. Projections done. The only thing that's left is some kind of a joining. All right, draw straight lines joining their top views. Now please remember, wherever there is a dash, it means it's a front view, and wherever there is no dash, it's a top view. So we need to join these two front views of both the points, that means P dash with Q dash, and we also need to join the top views of both the points, that is simply P and Q. So this finishes our problem. 2 points A and B are in the HP. So this time around I'll be writing down the given data simultaneously. So there are basically 2 points A and B which are in the HP. That means their distances from horizontal plane are going to be 0. So HA for point A is going to be 0, as well as HB for point B is going to be again 0. Right. The point A is 30 mm in front of VP. So the distance of point A from the vertical plane, that is going to be in front, is 30 millimeters, and it's 30. And one thing is for sure, that point A lies in the first quadrant. All right. Now let us shift our focus towards point B. While B is behind the VP, how much behind the VP? Oh, and this is the question which strikes me immediately. B is just behind the VP. Alright, but how much behind? Well, no such information has been given to us as to what is the distance. Alright, we don't know how much this distance is. But one thing is for sure, that point B is behind the VP, that we can say that P lies in the second quadrant. Alright. And let us read it further to extract some more data. The distance between their projectors is 75 millimeters. Alright, the distance between their projectors is 75. Fine. Do we have some more data? Where is it? And the line joining their top views makes an angle of 45 degrees with XY line. Oh, this is pretty interesting. Line joining their top views, makes 45 degrees. So this is the condition which we've got to use and incorporate in our drawing. Line joining top views makes 45 degree angle with XY line. XY is, I told you earlier, the popular line, the reference line. Alright, so let us start. We can start by drawing this point A. Point A is projection, that is going to be H is going to be above and D is going to be below XY. Alright, so 0 of this particular point A is going to lie exactly on the reference line, that is A dash is going to be exactly on the reference line because the value of H is 0. Alright, and D is going to be 30, that means below XY you need to go 30 mm. Okay, that's where you're going to find its top view. So let's do this quickly, and we need to start by drawing an XY line. Here it comes. Okay, so this is the very popular XY line, and we have distance for H is 0 and D is 30, so it's going to be somewhere here. H is 0, so it is going to be lying on the reference line, and D is 30. So with H you need to put a dash, and since the name of the point is A, it's got to be A dash, and this over here is got to be simply A. So this is front view, this is top view. Alright, and this dimension over here is going to be, or is 30 millimeters. Well, let's move forward. This guy, point B, it lies in the second quadrant, and the distance of projector of point B from that of projector A is 75. Alright, let us do this first. Distance of projector of point B from that of A is 75. That means, and one more thing that you've got to know is that point B lies in the second quadrant, and as far as second quadrant is concerned, the logic of H and D says that both of them, that is H as well as D, are going to lie above XY line. So one thing is for sure, that both the front view as well as top view for point B, they're going to be above this XY line. Alright, now one more data that we're going to use is these two datas have been used, and this logic has been used. Let me exhaust them, color them. Well, we are yet to use this data, that is HB is equal to 0. we know very well that h is going to lie somewhere here, okay, and hb is 0. Alright, that means it is exactly here, and with h you need to put a dash. So this particular point over here is nothing but b dash. Fortunately or unfortunately, the value of h is 0, so the front view is going to lie exactly on the reference line. Okay, now we have used almost all the data that were made available to us by the question, and this also has been used. The only thing left with us, and on using which the problem will be immediately solved or drawn, is this line joining top views makes 45-degree angle with xy line. So let us use this. Let us join the top views. Okay, but where the hell is the top view of point B? It's got to be somewhere here, but where is it? Well, we don't need it, man. We don't need it. Then how are we going to locate it? It's pretty simple. What we're gonna do is we're gonna start drawing a line, alright, at an angle of 45-degree. Now since this particular point A is top view and B is somewhere here, and we know very well that joining A with B creates an angle of 45-degree with this xy line. So what we're gonna do is we're gonna we're gonna keep a protractor over here, and at an angle of 45-degree we'll start by making a line, and we're gonna produce it until it reaches or intersects this vertical line somewhere here, and this is exactly what your point B's top view is. Alright, so let us do this quickly. So that's exactly the position of point B. Alright, now this, let us name it B. Alright, and well, that's it, folks. Point B, both front view and top view are above xy line. Alright, and something more is left. This also has been used, and find the distance of point B from VP. Okay, distance of point B from VP, that is distance D. So this distance works out to be as 45 millimeters. Alright, let us write this. Here it is. So the distance of point B behind vertical plane extracted from the drawing we've just made is equal to 45 millimeters. Well, is there anything left as far as dimensioning is concerned? I guess there is a little bit scope of dimensioning. This is 75. Alright, well, that's